The thing I wanted to share with you is about the review on electrostatic powder coating, principles and applications. So what exactly is the electrostatic powder coating? According to Weeks et al. 2007, these are coatings used in the finishing industry and are primarily designed to prevent metal corrosion, especially in an environment with high heat and moisture. These provide significant cost savings due to the improved performance and decreased processing times, as well as an environmentally and regulatory friendly service. Electrostatic coating involves the charging of particles, spraying or atomization of the charged particles, and the deposition of the charged particle onto the grounded substrate. So the deposited particles are then cured, usually by heat, to produce a film. The benefits of electrostatic powder coating includes the ability to coat without the use of solvents. That is undesirable from an environmental and operating cost standpoint. And also organic or aqueous, which is usually requires longer processing times and high energy consumption due to the slow drying rate of water. So because of the broad application of this technology, there is a substantial amount of information about electrostatic powder coating. And this involves three principles, which are: number 1, the principles of electrostatics; number 2 is the principles of film formation; number 3 is the principles of adhesion. So number 1, principles of electrostatics. It is where the particles can be charged by two mechanisms. Triboelectric or corona charging describes charge accumulation due to friction. This mechanism of charging results from the contact or rubbing of two dissimilar surfaces, the transfer of electrons from one surface to the other, followed by the separation of the two surfaces, resulting in the opposite charge surfaces or charge separation. Number 2 is the principles of film formation. In conventional solvent-based coating processes, the solvent and evaporation of solvent respectively act as a temporary plasticizer and to provide capillary forces to aid in film formation. So in number 3, which is the principles of adhesion, much of finishing industry involves the electrostatic powder coating for the treatment of metal surfaces. However, this has expanded to include surface treatment of substrate, such as woods and plastics. In pharmaceuticals, electrostatic powder coating is used since most of the pharmaceutical powders have high resistivity. They are prone to charge accumulation and slow charge decay. Combustion potential, weak flow properties, and powder adhesion to equipment walls are some of the industrial consequences. Number 1, the solid dosage form coating. And pharmaceutical coatings are now predominantly aqueous-based. However, the solids loading can still be relatively low and require long processing and drying times, which equate to higher energy inputs and cost. Number 2 is the drug delivery device coating. The application of coating for protective purposes such as to prevent corrosion is a primary driver in the finishing industry, but is also advantageous for coating of stents and or other implants. In addition to corrosion protection, coatings applied to stents can improve biocompatibility and enhance surface properties such as surface energy and texture. In number 3, which is the free film preparation, while tablets and capsules remains the most preferred oral dosage forms, difficulty swallowing or dysphagia can significantly limit their use in certain populations, such as pediatric and geriatric patients. So because of this, oral films are emerging as a promising dosage form for oral drug delivery. Electrostatic powder coating provides a unique advantage to utilize the innate charging ability of pharmaceutical powders to develop solvent-free processes with increased manufacturing efficiencies. Since this is a mature technology, much of the current expertise, such as particle size and resistivity guidelines, can and has been extended to its use in pharmaceutical manufacturing.